Good afternoon, everybody. Welcome to another exciting afternoon of organic chemistry with your host, me, Dr. White. Don't forget today, right after class and lab, I will be sending out an email with the password for test number 2, which is already in D2L. Download it, take the test, and then upload it as a single PDF file. And you have, I think I gave you till 10 a.m. tomorrow to do it. Take about an hour. Remember, you should not be looking at your notes. That's cheating. And I've got some secret things in my test to let me know if people are doing that. I'm not going to tell you what it is, but it's quite effective. And therefore, take test number 2. I guarantee by, let's see, what's today, Wednesday? Because I teach all day tomorrow and I got some stuff Friday. At the latest, by Saturday, 1 p.m., I will have your grades in D2L. And hopefully by then or the end of Saturday, if not sooner, I'll also be sending out an email with your individual points for each part of test number 2. And I think that's, Jason, yeah, you can print it out and write it on a pencil. And then, however, if you have a scanner, scan it in. I have files, and if you don't, it's in D2L, how to create a PDF file with a cell phone. And if you took test 1, whatever you did in test 1 worked for test, should do the same for test 2. And if you don't have a printer, just handwrite it out. Make sure you write your name on there so you know who you are. And that way, even if you don't have a printer, because I believe every one of my students either has or has access to a cell phone. I think in today's day and age, I would find it very hard to believe anybody who's a college student doesn't have a cell phone. It's sort of like having a pair of shoes. Well, not that basic, almost. All right. In terms of the PDF file, however, you can print it out or even just on a piece of paper. Problem 1, write your answer. Problem 2, you do not, if you're going to write out the test, and this is for everybody else who will be watching this video, you do not have to write the test questions. I have those already, and I usually have it in my head too. So just write your answers if you don't have a printer. Okay? All right. Today, what I'll be doing is continuing on with esters, which we were talking about on Monday, and then we'll have our lab. And remember, I switched them inadvertently. Last week we did the ketones and aldehydes, where we should have done the distillation. Well, this week we'll do the distillation lab. Doesn't really matter, but that happens. All right. I think I might have uploaded the wrong lab to where I'll get to it later. All right, let's get to work. Just a quick reminder, esters, which have this structure, which I don't think hold on one sec. All right, esters. Everybody see esters in nature on your screen? Thank you. Ester has this structure, carbonyl with an oxygen with a R prime, and the carbonyl has R group. And they're found throughout nature, a lot in perfumes, as I talked about on Monday, and other places. If you smell a banana, apple, pineapple, you're smelling it or tasting an ester. What other things are there? No, there are a lot of esters. Now, one interesting ester, if I'm giving you a headache, you have aspirin. And this is the structure of aspirin. You don't have to write this down, switches off. And notice here I have an ester. It's written this way. Where here's my carbonyl. It also has a carboxylic acid and it has a benzene ring, and that's aspirin. Now, how does that eliminate pain in your body? I have no idea. I'm an organic chemist. I know how to make it, but I don't know how it actually, the physiology, if that's the right word, of how it interacts in your body to eliminate pain. And we'll talk about other painkillers throughout the semester. Now, how do you make an ester? There's one way, and it's called Fischer Esterification. It's named after the great German chemist, Emil Fischer. Now, this reaction alone would be a lifetime achievement. However, Emil Fischer is really known for his work with simple sugars and carbohydrates, which was also a lifetime achievement. And later on, I'll tell you the same story, how some of the works Emil Fischer did, not with this reaction, but other ones, probably killed him. Sad, but true. All right, let's look at Emil Fischer esterification. And what you have is a carboxylic acid reacting with an alcohol in the presence of acid catalyst, and you make an ester. The important thing here is the carbon in the alcohol that has the hydroxyl group will be the carbon in R prime of the ester attached to this oxygen. So let's do some. And the question would be, what's the product or products for the following reaction? And now we're getting more complex ones. You look for what's different. What's this? What's different? Ooh, carbonyl, hydroxyl group carbons, carboxylic acid. Carbon, hydroxyl group on a carbon, alcohol. I'll call that R prime. And what do we have here? Acid catalyst, something like sulfuric acid. And what do you get? An ester. And now if we look at this, this is R prime.
And I'm not seeing anything.
Oh no.
Sorry to interrupt. I just, nothing's coming up.
No, don't be sorry about interrupting. All right.
There we go.
Instant replay. Let me rewind the tape. You ever have a real tape and rewind it? That's what it sounds like. All right, let's do it again. If I react this compound with this compound in the presence of this, what do you get? What's different up here? Carbonyl with the hydroxyl group and R group, carboxylic acid. Carbon, hydroxyl group on a carbon, that's an alcohol. Acid catalyst, you get an ester. This is R, as I have circled here. This is R prime. So now, remember, you don't break carbon-carbon single bonds. Other types of bonds I'll teach you can. Here's my R group. Here's my R prime. I know there are 4 bonds to carbon, so I can put in my hydrogens. And I've made this ester. Let's try one more. I'll do this one, then I'll let you have fun too. All right, can you still see it? Let me check with my thumbs up, people. You still see the whiteboard? Thank you, thumbs up, people. All right, I'll do this one. The question is, what's the organic product or products? 3 points each. And if we look at this, we say, ooh, what's different here? A benzene ring. But do you know the reaction of benzene with, this is an alcohol? An acid catalyst? I don't. So this is just an R group. What's here? Carbonyl hydroxy group. R group, carboxylic acid. What do we have here? Well, I gave it away. Carbon with a hydroxyl group, alcohol. We have H plus, which is acid catalyst. Something like sulfuric acid will do it. And there are other acids that I won't teach in this class that will also do it. And you get an ester. What's my R group? What's my R prime? My R group. Carbonyl, oxygen. Which carbon in the alcohol has the hydroxyl group? And the answer is that carbon. Therefore, that's the carbon that will be attached to this oxygen. And remember, you don't break carbon-carbon single bonds. And that's the ester you make. Oh, now it's your turn. Sorry about that. Fingers pushed a button on my stylus that it shouldn't have. I've been pretty good about that this semester. Your turn. And JC, when you're done, give me a thumbs up. All right, it's time to go ahead. Let's do this. Look at the molecules, look for what's different. Ooh, oxygen's here and here. Carbonyl, carbon double bond to oxygen with a hydroxy group and carbons. That's a carboxylic acid. Ooh, another molecule, carbon, carbon, carbon with a hydroxyl group, alcohol. I'll call that R prime. Acid catalyst, that's the H plus right there. And therefore, what do you get? This is a Fischer Esterification. And what's my R group? This isopropyl. What's my R prime? And propyl. And therefore, I'll do my R group. I'll have my carbonyl. I'll have my oxygen. And notice the N carbon of this R prime is attached to the oxygen, the alcohol. Therefore, it will also be attached to the oxygen in my ester. Oh, let's do one more. These are fun. And your turn. All right, everybody done? I think so. The whole 1,000 of you people out there. All right, let's do this. What's different? Ooh, oxygen here and here to the same carbon, carbonyl, carbon double bond to oxygen, hydrox group carbons here. This is a carboxylic acid. Plus, what do I have here? Carbon, carbon, hydrox group, alcohol. Acid catalyst, H+, and this is Fischer Esterification, which I'll never ask on a test, but I honor Emil Fischer, Dr. Fischer, for the work he did by saying his name. So it's my R group, methyl. What's my R prime? Ethyl. Therefore, R group, carbonyl. Oxygen, what's my R prime? Ethyl. And there we go. Anybody see the significance of this reaction? While you're doing that, I'm going to get a drink of water from my handy dandy water bottle. All right, time's up. What's the significance? Well, if you're trapped on or stuck on a desert island and you have vinegar, which is acetic acid right here, and you have vodka, which is ethanol right here, if you have a little acid around, you can mix two together, react it to make ethyl acetate, which is nail polish remover, which if you didn't have, you could now make and now take the nail polish off your nails. I always do that. It's a fun mental exercise I enjoy. Look at reactions and say, which things would help me if I was all alone trapped or stuck somewhere and I needed to make something. And that's that. Now, on test number 3, like test number 2, I will be doing synthesis problems, so I better let you try one. Now, this plus tells you there are 2 things there. And why don't you do it? What 2 things? And a test, I may not put question marks, but I'll always put a plus sign. That's my little gift to you. What 2 starting materials would I react with acid to make that compound? Excuse me. And this is the fun part of organic chemistry. But then I'm biased, I'm a synthetic organic chemist, and that's what I've been trained to do. And when you're done, oh, you both gave me a thumbs up, so I'm ready to go. All right, how do you do this? You look at the product and say, what's different? 2 oxygens to the same carbon, carbonyl, oxygen with carbons, I'll call it R prime, carbons on the carbonyl carbon, R, this is an ester. What do we react with an acid to make an ester? A carboxylic acid plus an alcohol. And what's my R group? Methyl. What's my R prime? Methyl. So my carboxylic acid would be this one, acetic acid. And my R prime is methyl, so I'd have methanol. And that's how you do it. If you're reading a book, I'm not going to talk about mechanisms in class, even though I'd like to. Real quick, switches off on this. When you have a cyclic ester, for some reason, someone decided, let's call it a lactone. And these are made from hydroxy acid, switches off for this slide. By the way, I should ask, everybody see lactones on your screen? Thank you. All right, now, once you have an ester, what can you do with it? Well, you can react it with acid and water. And you break it back down to the carboxylic acid you would have used to make that ester, plus the alcohol you would have used to make that ester. Now, this turns out to be a very important reaction. Well, you say that about all of them, but it is. And we'll talk more about it in depth later. But I would ask you right now, where you are in the room you're right now sitting, where would you find acid and water? Anybody know? Time's up. In your stomach. Your stomach has water and it has acid. In this case, hydrochloric acid. I always think of this as and feel it's one of the miracles of life that we all have cells in our body that synthesize, that's the fancy word for make, hydrochloric acid. That always just astounds me that my body can do that, and yours too. Well, it turns out, and I'll teach you later, this reaction, acid hydrolysis of an ester, or ester acid hydrolysis, is how your body breaks down fats and oils. When you eat something with a fat or oil, you have potato chips, French fries, or you had butter on something, or mayonnaise also has fat in it, or oil, if you had oil vinaigrette dressing on your salad. How does your body break down that oil or fat? By this reaction. But let's talk about it in terms of our class. All right, hopefully everybody sees my whiteboard now. If not, scream out. All right, let's look at the following. And sometimes I'll write it like this, which is the same thing as writing it this plus water with an acid catalyst. Organic chemists do it any of those ways. We're lazy. And what do I have here? And the question is, what's the organic product or product? An ester. What am I reacting it with? Water and acid. What do you get? The carboxylic acid plus the alcohol you would have used to make that ester. And it turns out, I'll teach you later, your body makes certain alcohols and carboxylic acids that it uses for other things. All right, therefore, what's our methyl? What's our prime? Ethyl. Remember, in this reaction, the carbon with the oxygen here in the ester will be the same carbon in the alcohol with the hydroxyl group. Again, the carbon in the ester, R prime, bonded to this oxygen, will be the same carbon in R prime over here with the hydroxyl group. So I have R, and then it'll be a carboxylic acid, and R prime, and that's what you get. Now, if you think about it, what's the significance of this reaction? Well, if you're on a desert island and you have some ethyl acetate nail polish remover and you want a stiff drink and you also want to make oil vinaigrette dressing, take the nail polish remover, react it with water and acid, hopefully you have acid around, and then you'll make acetic acid, which you can use to mix with water to make vinegar, and you'll make ethanol, which you can mix with water and have some vodka. but you didn't know Dr. White knows all these cool things about organic chemistry. And the question is, what's the organic product or products for the following reaction? Thank you, Samantha. Thank you, JC. And thank you, Dr. White. No, not really. All right, let's take a look at this. What do we have that's different? Look for what's not carbon. Look for what's not hydrogen. Ooh, 2 oxygens. And they're carbonyl. Same carbon has an oxygen. On the oxygen, I have carbons. I'll call R prime. Here on the carbonyl, I have carbons. I'll call R. Ester. Acid and water. And this is acid hydrolysis of an ester, and you get back the carboxylic acid and the alcohol you would have used to make that ester. What's my R group? Ethyl. What's my R prime? N-butyl. So I'll have my R group. What do I have next? My carboxylic acid. And then I'll have my alcohol, which I'm going to put up here so I don't run off the page. Oh, wait, hold on. Got more room. And now, what's our 4 carbons? Which carbon has the oxygen on it, the N1 of 4? So I have 1, 2, 3, 4, N1. Now, Dr. White likes putting his functional groups on the end. If you put it on this carbon, make it HOCH2, CH2, CH3, that's fine. All you've done is rotate this 180 degrees. And that's how you do this. Oh, let's do another one. Have some more fun. What would be the organic product or product for the following reaction? And remember, this general reaction is going on in your stomach right now. If you had anything in the last couple hours, I don't know how many hours, is resident in your stomach. And I guess someone corrected me. I think it's also your small intestine that breaks it down, but don't quote me on that. Last time I had biology was freshman year of high school. Whoa, that was a long time ago in a galaxy far, far away. And I think, is everybody done? I know one person is. Everybody's done. Thank you. Now, if we look at this, oh, wait, we got a benzene ring. That's different. But will that react with acid and water? And the answer is Dr. White doesn't know of a reaction. That's a nice way of saying no, it won't. But what do I have here that's different? Oxygen, double bond to carbon, same carbon as this oxygen. And we have this, on this oxygen, I have carbons, I'll call R prime. I have my benzene ring, I'll call that R. Ester, acid, water, and now you get a carboxylic acid plus the alcohol you would have used to make this ester. And what's our benzene ring? What's our prime? Methyl. And therefore, what do you get? You get benzoic acid, which I don't ask you to name it. And our prime is methyl. What am I doing? I'm thinking a problem ahead of myself. Sorry about that. Sometimes when I'm doing a problem, I'm thinking about what am I going to be doing next and more to do. No, I was right. R prime is our methyl. And that's what you get. Everybody hold on while I reboot. All right, I've rebooted. My brain's working again. Hi, Alondra. All right, let's do one more. And that's the synthesis. What would you react with acid and water to make these two compounds? And I've actually worked for a company that did that stuff. To make carboxylic acids and alcohols, which we sold to the tune of about 2 to 3 million pounds a week. And when you're done, give me a thumbs up or a thumbs down if you don't like doing this problem. Oh, wait, they don't give you an emoji for that. Did I pronounce that right? I think so. All right, let's do it. What do we have that's different here? We have a carboxylic acid, carbonyl hydroxyl group, and an alcohol. And what do you react with acid and water to make a carboxylic acid and an alcohol? And the answer is an ester. And if we look here, what's our two carbons attached to my carbonyl? What's our prime? In this case, CH3 attached to hydroxyl group. Therefore, I have my two carbons, then a carbonyl, oxygen, and R prime. And I put in my hydrogens because I know there are 4 bonds to carbon, and I'm done. And that's acid hydrolysis of an ester. And like I said, we'll come back to this later in the semester when I talk about fats and oils. Now, another important reaction of esters is called saponification of an ester. And it's a key organic reaction. And this has been used, I better ask, everybody see that saponification on this? Thank you. If not, scream at me. And if you want to scream at me anyways, you can do that too. But anyways, and I'll show you later in the semester, it's used to make soap. Our ancestors found this out. Now, what is saponification of an ester, or sometimes called base saponification, or just ester saponification? If you take an ester right here, and react it with base, and I'm going to rewrite this a little, where M can be, excuse me, lithium, sodium, or potassium. What you get is not the carboxylic acid you would have used to make, this should be an ester, sorry about that, the ester, you get the carboxylate anion of the carboxylic acid plus the alcohol you would have used to make that. Now, what I'm going to write on the screen, you do not have to know, but the question is, why do we get this carboxylate anion instead of the carboxylic acid? Well, if you had base and water, where M in this case is either lithium, sodium, or potassium hydroxide, what you get is the carboxylic acid plus the alcohol you would have used to make that ester. But whenever you see an organic chemist put stuff in brackets, that means it's not isolated, because you learned earlier that a carboxylic acid will react with base and water to give the carboxylate anion. Now, the second reaction right here that I just wrote is called diffusion control reaction. It's the fastest reaction in all of chemistry, all of nature. It happens almost instantaneously in a billionth or a nanosecond. It's that quick. And therefore, when you do this reaction, you will not get the carboxylic acid. You'll get the carboxylate anion. If you write the carboxylic acid, I mark it wrong because you can't. Now, it turns out saponification, like I said, is how our ancestors made soap. And if you use bar soap, that's it is, the carboxylate anion, which I'll teach you later in the semester. Let's do this reaction. I'll let Dr. White do it, and then I'll let you have some fun. We have this molecule reacted with base and water. What do we get? Well, if I look up here, I have an ester. Carbonyl, remember, look for what's different. My 2 oxygens to the same carbon. And what am I reacting it with? Base and water. Remember, M can be lithium, sodium, or potassium, and you get the carboxylate anion of the carboxylic acid you would have used to make that ester, plus the alcohol you would have used to make that ester. And therefore, if I look here, what's our methyl, what's our prime, and propyl? Remember, the carbon with an R prime bonded to this oxygen will be the carbon and R prime here with the hydroxyl group. So my first one will be R group, then this carboxylate. This is called sodium acetate, the common name, because M is sodium, and my R prime is N-propyl. And that's how you do it. Your turn. And what would be the organic product or products? And on a test, I'd probably do this to let you know you get two things. More than probably, I will. Have fun. Remember, smile while you react. Ooh, that was awful. What was the one? Oh, whistle while you work. Was that from Snow White and the Seven Dwarfs, I think it was. You can tell my brain's been brainwashed by Disney. Even though they did do a lot of great things, they're still doing a lot of great things on screen. How many of you have ever seen Steamboat Willie? If you don't know what that is, that's, I believe, the very first Mickey Mouse cartoon Walt Disney did. It's on YouTube. It's really funny, which is why he became so rich and good at that. All right, everybody done? Give me a thumbs up if you are. All right, thank you. All right, what do we have here? Carbon, what's different? Ooh, oxygen here and here to the same carbon. Carbons here, ester. What are we reacting it with? Base and water. What do we get? The carboxylate anion plus the alcohol, the carboxylate anion of the carboxylic acid you would have used to make the ester, plus the alcohol you would have used to make that ester. What's R? These two carbons. What's R prime? T-butyl group. Therefore, I have my R group, carbonyl. My M, in this case, remember, M can be lithium, potassium, or sodium. Actually, it can be other things, but for this class, I'll limit it to that. You don't have to put charges here if you don't want to. Dr. White does. And my R prime is T-butyl. Notice the center of 4 carbons has the hydroxyl group. And that's how you do it. Oh, let's have fun with one more. And why don't you try this one? What would you react with sodium hydroxide and water to make these two compounds? By the way, oh, that's an H. Let me fix it up. On the board, I do the same thing. Sometimes my H's look awful. The closer we get to important information, important election, the worse my hydrogens look. Oh, oh, one done, but take your time. Two done, three done. All right, all 100,000 of you out there are done. All right, question is, what do you react with this sodium hydroxide and water to make these two compounds? What are, first of all, let's call this MOH, where M equals sodium, lithium, or potassium. And what do we have? Ooh, carbonyl with the oxygen minus and a cation, carboxylate anion. Again, look for what's different. Sodium is sure different. And then, ooh, here, carbon with a hydroxyl group and alcohol. And what do I react with base and water to make a carboxylate anion and an alcohol? And the answer is ester. And if we look here, I'm going to call that R. I'm going to call this R prime. And how do I build this over here? First of all, I need some more room. And my R group is methyl. I'll have a carbonyl, oxygen. My R prime is ethyl. Whoa. My fingers hit the button on my stylus, which I didn't want to. That's one bad thing about this product, or the fact that I just have big fingers. And that's the starting material. You react with sodium hydroxide and water to give this product. Now, let's take a 5-minute break because my back is telling me to take a 5-minute break, get up and stretch. I'll see you in 5 minutes. And it's lab time. We'll be out of here by 10 after 2, quarter after 2 at the latest. For those who don't know, when the big hand is on to either 2 or 3. I'll see you in a couple minutes. All right, let's get back to work. By the way, I was just checking on the internet. One, they just busted Giuliani Borat or Borat. Thought he was talking to a female journalist and well, he was doing something inappropriate to try and get her attention. Weird times we're living in. I mean, really weird. All right, let's get back to something sane and normal, organic chemistry. Are you ready for a lab? And the answer is yes, I am. So let's do it. All right. The question is, thank you, JC. All right, question is, what if you have a mixture of liquids and it's not pure and you want to get pure substance? Sometimes when you do a reaction, things don't all fully react, so you have some starting materials left with your product. Or what if you do a reaction like I just showed you, where you make two products? What if you want to separate them so they're pure? Well, if they're liquids, we use what's called distillation. And distillation takes into account that different compounds have different boiling points. Oh, warning, I'm going to do some artwork, so hang on to your desk or something. I don't want you laughing so hard you'll fall off and hurt yourself by falling onto the floor. All right, now let's talk a little about boiling. Well, first let me show you the lab. And when a liquid boils, vapor is formed. Vapor is just a way of saying it's a gas of that compound at a temperature where it normally would be a liquid. Right now you're surrounded in the air by water vapor, which is just water in a gas form. Now, let's look at it. I have it written here, but let me just describe it on the whiteboard. Again, look out, artwork. Mother was an amateur artist, none of it rubbed off on me. Let's say you have a beaker with water in it, and you put it on a hot plate. It's got a little dial and you got a little cord. And after a while, you'll see little bubbles here, and they'll float to the surface and collapse. And what happens is, when they collapse, inside those bubbles is water vapor. And gas, if you remember from your general chemistry, has a pressure you can measure. And when the partial pressure of the bubbles, water vapor, equals the atmospheric pressure, that temperature is called the boiling point. Now, I should point out something very important. When you boil something, you see these little bubbles form in. I think you've all boiled water on top of a stove or in a teapot, and you'll see the steam coming out. Steam is a word we use for water vapor, and hot water vapor actually, and you'll see the bubbles come up and collapse. Now, when you do it, you're probably doing it in a pot or pan, which is made out of metal. And even though the metal will feel real smooth, if you look under it under very high magnification, it's quite rough. It's like the Grand Canyon, all the nooks and crannies on the surface of the metal. And those rough surfaces help bubbles form and come up like you see in boiling water. Well, if you do it in glass, even if there's scratches in the glass, it's smooth. And what happens is, if you don't put something in when you're boiling in glass called boiling chips or boiling stones, it forms these monster bubbles and go boom. And we call that bumping. And bumping is bad. I once saw where some idiot forgot to put the boiling chips in his distillation. It bumped and the thermometer shot up and stuck in the ceiling tiles. in that lab. We let him know how dumb he was. So what you do is, to make sure it doesn't bump, anytime you're in glass and we're in a lab where you're heating a beaker of water, you'd put in boiling chips. Or boiling stones. In this, at ECC, we use carborundum chips and metal chips that are in just about anything. At the other school, we use marble chips, which are just about anything inert or organic. Now, when you set up a distillation, we have what's called a round bottom flask. And in here, you put your boiling chips. Now, we'd have this clamped up. You'd have what's called a heating mantle. That's like an electric blanket or heating pad that gets quite hot, goes up to a couple hundred degrees Fahrenheit. You can burn yourself by touching the inside of that. I always warn students don't. Now, right here, if we're in the lab, and this is the actual setup we use, you'd see up at the neck here of this round bottom flask, these are called round bottom flasks. And I've used some that are so cute. But anyways, you'll see this is sort of rough, and over here, it's rough too. And that's called a ground glass joint. And you always have to grease those before you put them together, so later on you can take them apart. This is your still head or distillation head. Here you have a thermometer adapter and a thermometer. Now, a couple years ago, ECC spent the money, so both my lab and the other 2-semester organic, we came into the 21st century, and instead of using a thermometer, we use thermocouples with a meter readout, which is nice. Now, over here is your condenser. Now, if this is all hooked together, your vapor, oh, hold on, I'm gonna go Technicolor on you. Your vapor comes up here. Your thermometer would actually be right here, and heat the thermometer, then comes here. These are closed together. And here we have our condenser. Now, the condenser is 2 tubes, an inner tube and this outer jacket. And what you do is water goes in always at the bottom, and water always comes out at the top. Why? Because you want this whole inner jacket to be full with water. And what it does is cool down the vapor here to make actually liquid again that you can collect. I told you my artwork is in. And over here, this, which we won't use, is to allow you to pull a vacuum on that to do what's called a vacuum distillation, which I've done. I've done more in my life than I can even remember. And when you pull a vacuum on something, you lower the boiling point, and certain things you distill, you don't want to heat too much, so you do a vacuum distillation that keeps the temperature lower, and also protects that molecule from what we call decomposing from the higher temperature. Now, once again, it's real important that the water always comes in at the bottom and goes out the top. Because if it didn't, you put it in this way, the wrong way, you just see a little water there, and the rest of this would not fill up, and it wouldn't work that well. And this is a condenser. By the way, it took me 2 years to convince ECC to buy this equipment. The sets, if we were in ECC, are about $1,500 a piece. Each group has one. You work in pairs. Now, important other thing. How many of you have ever cooked rice or noodles in boiling water? Do you fill the pot all the way up to the very, very top with water? No, it'll boil over. Well, the same thing with a round bottom. A round bottom, like here, you never fill more than about 75%. Because otherwise, this can all come over. And if this is a mixture in here, you'll get everything coming over and contaminate whatever you're trying to purify over here. And that's the distillation. Now, one of the important things when you're doing a distillation is what's the boiling point of what you're purifying. And how do you determine that? You look at the thermometer or the thermocouple, and when the temperature is level, 3 more rings and they'll stop. I think I know what it is. 1 more. By the way, that's my Bluetooth amplifier. Stop. Thank you. All right. While you're doing this, the heated vapor is coming up here and will cause the temperature to increase. And when the temperature is level, for a couple readings, that's your boiling point. By the way, I do this in the classroom or in the lab where I pull up the screen and it's projected onto whiteboard, and I can do the same thing. Now, I have here a couple of YouTubes so you can see the same setup. I wish you were around. Now, important thing, which I warn students, you never allow a distillation flask to go dry. Why? Because there might be some chemicals that get overheated and explode. So you always stop when there's some. Now, in this lab, you'll be setting up here's the procedure. I'll let you read it on your own. I would highly recommend you look at one of these 2 YouTubes. I tell you, everything's on YouTube, I think, except my high school graduation. I'll look for my PhD graduation. Now, normally, you would be collecting at various amounts in a graduated cylinder, 2, 4, 6, 8, and so on, up to 14 milliliters. You'll be distilling or would be distilling hexane. And along the way, you'd record the temperature. And this is important data you'll need later on. And really part of this lab, which is sad, is you get the experience to set up a distillation. And here are the questions for you to answer. Now, one last thing I need to talk about. How many of you ever heard of moonshine? And if you've ever seen the program, I've watched it once or twice, and I've had enough, because it's a synthetic organic chemist who've done industrial distillations up to about 250,000 pounds. That's like, how many? 6 tank wagons, you know, the long vehicles that deliver gasoline to a gas station. What the moonshiners are doing, how many of you heard they use a still? Still is this shorthand for distillation apparatus. They have something they heat up, and because a lot of times they're out in the middle of the woods to keep away from the police, Do not try making your own moonshine. I think it's still legal in the United States, but they have a long copper tube on top and it collects it. Since they don't have water, the long copper tube, how do you like that? I'm doing that pretty good. The long copper tube is surrounded by air, and that gives like a condenser with water, but now you don't have water. It takes longer time to cool down the vapor to liquid. And what they're doing is they're distilling ethanol away from their mash, and they get a little water to come over too. That's another thing I won't be teaching about steam distillation. And they make their liquor. So next time you see where they're talking about their still, they're actually talking about doing a distillation. And with that, I'm done. Remember, in about 5 minutes or so or less, I'll be sending out the email for test number 2. You have until tomorrow morning to do it and send it back as a single PDF file. And I'll be checking my email every couple hours today. If you have any questions, send me an email. I'll also have my office hours. If you have questions, stop by. I will not give you the answers, but if you're not sure how to do something, have a question about the problem, I'll answer. If we were in a classroom, I would do the same. So with that, I'll say, game gesund, be healthy, have a nice rest of the week and weekend. Don't forget, by Saturday, I'll post the grades. On Monday, I'll go through the answers to the test, but as in the email you'll get, I will be eliminating, taking it out of the video. But if you can't make it next Monday to class, come to my office hours anytime and I'll show you the answers. With that, I'm out of here. Bye.